Hello everyone, I hope you are all doing well. In the previous class, we discussed a few of the concepts present in the search engines. What are they? Search engine. So simply we can call it as what is a search engine, what are the applications of the search engine, who is a search engineer, what are the responsibilities of the search engineer, what are the goals of the search engine, what is the architecture of the search engine, what are the basic building blocks. In today's class, I am going to brief about the next concepts present in the first unit as follows. So these are the contents I am going to cover in this class. The one is basic building blocks. As part of the basic building blocks, we are going to cover and in detail we are going to talk about what are the internal components of those two building blocks and it's breaking it in a very clear manner. And we are going to know how does it really work. So these are the concepts we are going to cover in this class. First, we will have the glance on what are the basic building blocks. We already studied that. We are having majorly two basic building blocks. One is indexing process and another one is the query process. So what indexing process is responsible for and what the query process is responsible for. When you try to understand the indexing process builds the structures. So it is going to build the structures that enable searching, and what the query process is responsible for. Query process is going to take the input from the indexing process and it is going to take the user's query. So along with the user's query and the data structures given by the indexing process, so one can going to generate the ranked list of documents. So the query process is responsible for, so it is going to take those structures and person's query to produce a ranked list of documents. As I already discussed about one of the popular algorithm proposed by the Google, so page ranking algorithm. Founders of Google are proposed this algorithm and this algorithm is working like this. So whenever the users having more visiting about one particular page or the website, those pages or those links are able to display in an order. So page ranking is algorithm working like that. And here the main building blocks are indexing process and another one is the query process. Now we will see the indexing process consisting of three major components. They are, one is the text acquisition component. Text acquisition. It is responsible for identifying the documents. And text transformation, this is the second component we are having, so which is going to convert the documents into the index terms. The text present in the documents are going to be converted into the index terms. And the third one is the index creation. The index is going to be created here and finally the index will be presented. When you observe in this diagram, here you will be having email, web pages, news articles, memos and letters. So the World Wide Web consisting of all those documents. Whenever all the documents are gathered, so among all the documents, the text acquisition phase is going to identify the documents required for the web search query. Now, so you already know that the document data store is the database which consisting of a lot of text documents and the metadata. Now we will have the glance on the points of the indexing process when you try to understand the text acquisition. So the text acquisition is responsible for identifies and stores the documents for the indexing. What are the documents that are available in the web? They will be identified and they will be stored for the indexing process. Now the text transformation phase, the text transformation. So what the text transformation is responsible for? So whatever the text documents are identified in the text acquisition phase, so all the text documents are going to be converted into the index terms or the features. So this is the word which we are popularly using in the field of machine learning. So here index terms and features are the outcome of the text transformation, and the third component is the index creation. So it takes the index terms. So in the index creation, index terms will be taken and creates the data structures. So we can simply call them indexes to support fast searching, to support the fast searching. So they are the three main components. One is the text acquisition component, and another one is the text transformation component, and the third one is the index creation. Finally, you are going to create the index. So you are going to create the index. So this is about the indexing process and the components present in the indexing process. Next, we are going to know about the query process. What the query process here? So we already know that the query process is going to take the indexes from the indexing process and going to use the person's query to produce ranked list of documents. As part of the query process, if you observe here, we are having again three more components. One is user interaction. One is the user interaction component. So if you observe here, here is a person. What he is doing, he is able to interact. For example, whenever you are before the Google, so what you are going to do is, so you will be having a user interface. So whenever you want to find any particular information or retrieve any information from the web, so you are supposed to face the Google. So www.google.com you open. You are able to find one of the user interface there. So Google, under that you will be having a text box you are able to identify. Under that you will be having two buttons. One is search button and another one, I am feeling very lucky. So Google, and whenever you want to enter any text data, so here when you observe the user there, so it acts as Google is going to act as a medium between user and the system. So user is going to interact. So whatever the text you want to enter here, you will enter here. The text, whatever you want to enter, you enter here. It is going to take, and that web search query is going to be processed, and again it is going to display the results also. It is going to display the results also. So here that's about the user interaction component, and the next one is the ranking. This is the one of the core component of the query process. One of the core component of the query process. So as we already familiar that the word page rank. So you will be having the page rank. So page rank. So this is the algorithm proposed by the Google, which was popularly used by the Google company, and so there are so many retrieval models. So they are the basis for the ranking, and again going to perform the ranking operation for producing the ranked list of documents. And finally the evaluation. The evaluation, it is responsible, and we want to monitor the performance. If you want to monitor the performance, then you can go with the evaluation. Then you come to know how the search engine is working, the performance of the search engine, whether is it best or average. So in that case, you are going to monitor the performance of that search engine. And here the log data, how the users are interacting, how much time they are spending, and the click-through data, they all will be maintained in the log data to improve the performance of the search engine. When you see here, this is the process you are depicting very clearly, that the process, as part of the query process, you are able to identify that. So here user interaction, what it is doing, supports the creation and refinement of query, display of results. It is going to display of results. And the second one is the ranking. So uses the query and indexes, to generate a ranked list of documents. And the third component is the evaluation. So when evaluation, so monitors and measures effectiveness and efficiency. So we can say it's primarily the offline. Here the user interaction and the ranking, and the third one is the evaluation. So these are the main three components of the query process. Now we can go in detail about each and every component in a very clear manner. So that's what the indexing process consisting of three components. One is text acquisition, and next text transformation, and the index creation. So they are the three main components of the indexing process. As part of the text acquisition component, we are going to find all the components as the first one is crawler. In the next slide, we are going to know about in detail about each and every component of indexing process and query process. So the first one, indexing process. Second one is the indexing process. We will see the components of the indexing process. The first one is text acquisition. Next, second one is text transformation. Next, third one is index creation. Now we are going to talk in detail about every component. So the first one is the text acquisition. We are going to discuss about the text acquisition. Again, the text acquisition, having it breaking it down like the crawlers and the feeds and the conversion, and the fourth one is the document store. They are the internal components of the text acquisition. Now we will see each and every component in a individual manner. So the first component is the crawler. So what is a crawler? Crawler, or we can also call it as spider or boat. So we can simply try to understand the meaning. Crawling, it's nothing but the moving. So when you understand about spider, so how it can crawl throughout moving of one place to another place in a scattered manner. So like that, here the crawler, whenever you are trying to understand the responsibility of the crawler, we are able to understand how the spider will move. So we will be having a huge collection of the documents in the web. Whenever you are searching for any particular information on the web, it is going to identify the different documents on the web. What are they? So here different documents are at different locations. Whenever it is going to identify it, one of the main component of the text acquisition is crawler. What the responsibility of the crawler? So the crawler having the main responsibility of identifying the documents. So just now I told you that the crawler or crawler is also known as spider or boat. So spider, what it can do, it can move from one place to another place in a scattered manner. So whenever you try to understand web, it is consisting of huge collection of the documents. So whenever the crawler is working, it is able to spread across the World Wide Web, and it is going to identify the documents which are stored in the scattered manner. Here when you try to understand, the crawler component has the primary responsibility of identifying and acquiring documents for the search engine. So here for example, you are before the Google. So you will be having the Google. So you will be having the text box there, and you are having two buttons. One is search button is there, and another one, I am feeling very lucky. So you want to know about one of the particular information about Gandhi Garu. So whenever you enter the data, what the crawler is responsible for, it is going to identify the documents about all the documents present in the World Wide Web about the Mahatma Gandhi Garu, and it is able to display as ranked list of documents. So that's about the responsibility of the crawler. So here the web crawler is the one of the general example for the crawler. What it is going to do, a web crawler is designed to follow the links on the web pages to discover and download the new pages. It is going to discover and download the new pages. Here we'll be having some of the classifications in the web crawlers, like according to the responsibility of the web crawlers, we can simply classify them as like this. So here you will be able to identify site search. So that's what a web crawler can be restricted to a single site. So that's what we are simply calling it as a site search. And we will see some more web crawlers like this, focused or topical. So the main responsibility of these crawlers are they will be specific to the particular domain or the particular topic. So that's what about focused or the topical. So web crawlers uses the classification. So we already know that the classification. So previously class labels are assigned and all the class labels are assigned for that, and it is going to identify the class labels. So that's what here that is specific to the particular domain or the particular topic. So here which restricts the pages or visited to those that are likely to be about specific topic. This is about the only specific topic. And next one is the enterprise search. The crawler is adapted so to discover and update all the documents, and it is going to discover and update all the documents related to one company's operation. So this is what we can simply understand. It's an intranet. Within the company, it is going to identify the documents. So that's what about the enterprise search. And next one, document crawlers. So we used for desktop search. We can use them for the desktop search. And along with this, in this case only, users' personals dictionaries need to be scanned. Just only the personals. So this is about the crawler. For the better understanding, I am going to brief about this crawler in a detailed manner. So try to understand here. What is the crawler and what is the responsible for? So the crawler is going to identify and discover and able to store the documents. So crawler, what is the responsibility of the crawler here? So for example, you will be having the spider like this. So there are so many documents are available in the web. Whenever you are before the Google, I just shown you that. So the Google is here, and you will be having a text box, and you will be having two buttons. One is search button and another one is the I am feeling very lucky. So for example, when you entered any one of the particular web search query you want to enter about Mahatma Gandhi Garu, you want to know about. You enter, and whenever you hit the search button here, whenever you hit the search button. Now, as part of the indexing process, the crawler having the main responsibility as it is going to scan the entire World Wide Web. So these are all the different documents are available in the entire web about the Mahatma Gandhi Garu. So the crawler is going to scan and it is going to search all over all the documents available on the web, and it is going to store as for the next process of the text transformation phase. So this is about the responsibility of the crawler.
Okay, good.
So as we see that different crawlers. So for example, if you are having the responsibility of the crawler as if it wants to search for the only one particular site, it is simply calling it as site search. We are calling it as a site search. So now the second one is about focused or topical. This is about one particular topic. For example, whenever you are trying to search about any particular video or any particular document, so those documents are going to be identified with the classification. Here, how the classification is going on, so whatever the documents are already available or whatever the videos are available, they are assigned with some of the predefined class labels. So those class labels are going to be identified with this type of the crawler. So that's what this is only particular about the particular topic, or which is specified to the only particular domain. That's what about the focused or topical search. And next, third one is enterprise. So this is particular for one particular university or one particular organization. Within the intranet, it is going to identify the documents and store the documents, and it is about the enterprise. And the third one is documents, document crawler, which is going to identify the documents present in the desktops. So that's about the responsibility of this crawler. So this is about the crawler. The crawler is main responsible for identifying and storing the documents among the web, and what it can do is it is going to scan the entire web. What are the different documents about one particular topic? They will be scattered in the entire World Wide Web, because the web consisting of huge millions of the documents. Whenever the millions of the documents are available, whenever you are going to try to search for the particular topic, how it is going to be identified. For example, you will be having a web search query. Here I entered as a web search query as the Mahatma Gandhi. Now Mahatma is the one of the particular word and Gandhi is the one of the particular word. Here entire you are calling it as one phrase or one sentence. It is a combination of different words and different characters again. How it is going to be identified by the Google, and how it is going to be given the response about only the Mahatma Gandhi Garu. So this is what about the next process, what about text transformation and index creation process will be done. Finally, the index will be created. So that's about the crawler responsibility. And now the main responsibilities of the crawler are, it is going to identify, discover and storing the documents. This is the main responsibility of the crawler. The next component is the feed. So what is feed? It is going to identify so that document feeds or the mechanism for accessing real-time stream of documents, for identifying the real-time stream of documents. Real-time stream of documents. So here what are the real-time stream of documents? So we'll be having number of videos, number of images, number of zip files. There are number of documents are available. So if you try to understand these two, crawler and the feeds, both are having most probably the same responsibilities, but a little bit variant when you try to understand it here. For example, a news feed is the constant stream of news stories and the updates. News feed is the constant stream of news stories and the updates. So it is going to news streams, and the second one is the updates. News streams, what are the news stories and updates. And in contrast, if you want to in contrast, a crawler which must discover new documents, a search engine acquires new documents from the feed simply by monitoring it. So here the feed, what it can do, it can see continuously monitoring. So whatever the news feeds are there and what are the updates are available, accordingly it is going to identify. So RSS2 is the common standard. It is the common standard used for the web feeds for content such as news, blogs or the videos, whatever it is. So RSS2. And the next component is the conversion. What is conversion? So simply you can understand the conversion. converting from one format to the another format, converting from one format to another format. For you, we know that the web consisting of huge collection of the web documents. Among all the documents, what it is going to do is it is going to retrieve the few documents. So like PDF documents or HTML documents, there are number of documents are available. Among all those documents, they are not in the same text, so they are not present in the text. So they are having different textual formats, like they will be having different formats like PDF documents, HTML documents, Word documents. Number of documents are available, and each and every document consisting of the text, but they are not in the same format. Here, according to the convenience, so that is going to be converted. So that's what the conversion you can understand. The document found by the crawler or provides the feeds rarely in the plain text. It's obviously read in the plain text. Instead, they come in a variety of the formats such as HTML, XML, Adobe PDF, Microsoft Word, like that we having. And here, more search engines require that these documents to be converted to the consistent text plus metadata format, consistent text and the metadata format. If you see in this one, so you'll be having like HTML, XML, Word, PDF and documents, etc. And here for converting, encoding different languages using the Unicode standard, like so this is the one UTF-8. And the next component is the document data store. So this is the database. So what is document data store? It is database. It is a database which consisting of huge collection of the documents. It's a database used to manage large number of documents and the structured data that is associated with them. The document contents are primarily stored in the compressed form for efficiency. So you are able to find one word. So that's what the compression. What is compression and why we are going for the compression? So you know that database consisting of huge collection of the documents. Whenever the indexing is to be created and whenever it is going to be accessed, the compression is also very important. What the compression is indicating here, whenever you will be having huge collection of the documents, to process that data is a very difficult task. So when you go for the compression, here compression will obviously improve the fastness. So you'll be having a huge collection of the documents, and the compression plays and improves the efficiency. The structured data consists of the documents, metadata and other information extracted from the documents, such as links and other text, anchor text that is associated with that link. So this is about the document data store. So these are the four main components of the text acquisition. One is index creation. Text acquisition is present in the indexing process, that consisting of the first one is crawler, and the second one is the feeds, and the third one is the conversion, and the fourth one is the document data store. And we try to understand the document data store in a more detailed manner. So whatever I already explained, so stores the text, metadata and other related content for the documents. So metadata is information about the document such as type and creation data, and other content includes the links and the anchor text, and which provides fast access to the document contents for the searching components. So result list of generation, and could be used relational database system, and it also uses relational database system. More typically and more efficient storage system is used to huge number of documents. So document data store is mainly responsible for that. It is a database, and which consisting of the huge collection of the documents that will be maintained as a compression format. And the next component is the text transformation component. As part of the text transformation component, we are going to identify, so these are the components of the text transformation. One is parser, and the second one is stopping, third one is the stemming, fourth one link analysis, information extraction, and the last one is the classifier. Now we will see in detail about the parser. So what is parser? Parsing. So whenever you try to understand processing sequence of tokens, the parser is main responsible for processing the sequence of tokens. It is going to process sequence of tokens. And in the document, to recognize structural elements such as titles, figures, links and headings. So parser is responsible for processing a sequence of tokens. Here one particular word you are going to understand: tokenization. The text is important first step in this process. And here in many cases tokens are same as words. As I just explained about, for example, Mahatma Gandhi. So here you will be having the two words Mahatma and the Gandhi. Again you will be having individual words M, A, H, A, T, M, A. So the smallest individual unit we can simply call them as the token. How these words are going to be processed? So as by each and every character by character. So that's what we are going to study about this parser. And the next word is the stopping. The next component is the stopping. What is stopping? Here the stopping is mainly responsible for to stop some of the words. For example, whenever you will be having web consisting of huge collection of the documents, the huge collection of the documents present, they are consisting of a lot of textual information. So for example, collection of documents. The documents consisting of a lot of textual information. For example, whenever the one document is going to be processed, the document consisting of number of index terms. Out of all the index terms, some of the terms like on, of, an, the, a, some of the words which will occur very frequently, and those words do not to be repeated in every time the process is going on. Those words will be stopped. That process we are simply calling them as the stopping. The stopping component has the simple task removing common words from the stream of tokens that are become index terms. So what are the index terms? It is going to be identified. Those words will be removed. So that's what we can simply call it as the stopping. And the most common words are typically the function words. We can call with another name as the function words. We can also call them as the function words. And here the examples what I told you, the, of, to, and for, they are all. And those words will be stopped. Here the main responsibility of the stopping is removing the common words. And next, stemming. So this is the word we try to understand. What is stemming? For example, whenever you are working with one particular word, for example, consider the word fish, fisher, fisherman, fishing. So out of all the words, one common stem is there, that what we can call it as a fish. So here in this example, the common one is the fish. So that's, we can simply call it as the one of the stem of this entire words. So this stems will be identified. Stemming is another word level transformation. The task of stemming component is group words that are derived from the common stem. So here the words, these are all the words derived from the common stem. That word is the fish. That word is the fish. And here the same example I explained, fish, fishes, fishing, one of the example here, and you are able to identify what the common stem here, that is what fish we can try to understand. And next, by replacing each member of the group with the designated word, for example the shortest which is in the case fish in this example, right. So this is about the stemming. And the next one is link analysis. What is link analysis? You try to understand. So there are huge collection of the documents are available in the web. Among all the documents, so each and every document is associated with the one particular link. So that is what anchor text we can call it as. So that link associated with the text. So whenever you are trying to search for any particular information, it is going to identify the links. So the link and the corresponding anchor text in the web pages will readily be identified and extracted during the document parsing phase. So here the extraction means this information is recorded in the document data store and can be indexed separately, most from the general text content. And web search engines make extensive use of this information extract through link analysis algorithms such as PageRank. So here one of the algorithm, PageRank. For example, you will be having a graph. So it is consisting of 4 nodes, for example N1 and N2 and N3 and N4. Here you will be having the graph. Each and every node is representing a web page. Whenever you hit the search button of the Google, it is going to identify the different nodes in the web and able to retrieve the information. But out of whenever it is going to display these pages, how it is going to display? Based on what it is going to display? It is going to display in one particular order, either N1, N2, N3, N4 or N2, N1, N3, N4, like that. So based on the rank of that particular page, it is going to be analyzed and displayed as part of the ranked list of documents. The main responsibility is the page rank is it is going to display the ranked list of documents. So this is about the link analysis phase. And the next component is information extraction. So here instead of going with one particular word or small words, it is going to identify as the information as a more complex. As a more complex information extraction is used to identify the index terms that are more complex than the single words, more complex than the single words. So here it is going to identify as the words in bold or words in the headings, but in general way it requires significant of additional computation is also required. Additional computation is also required. So this is about information extraction. So information extraction is used to identify index terms that are more complex, So classifier, the classifier. What is the responsibility of this classifier? So I told you that the classifier component identifies the class related metadata. Class related metadata for the documents or parts of the documents So there are a number of documents are available. They are all documents are labeled. all the documents are labeled. How they are labeled? They are labeled with predefined labels, and accordingly they are going to be identified. So the classification technique assigns predefined class labels to the documents. These labels typically represent topical categories such as sports, politics, or business. Sports, politics, or business. Next, the task of document statistics. The task of document statistics component is simply to gather and record the statistical information about words, features, and documents. Words, features, and the documents. So this is about the text transformation and its components. And here, whenever you try to understand, the entire text transformation is all about transforming the entire text into the index terms. As part of the transforming the text into the index terms, we come to find the different components, like what are the different components: parser, stopping, stemming, link analysis, information extraction, and the classifier. And the next component is index creation. As part of the index creation, we are going to identify these components: document statistics, weighing, inversion, and distribution. I will try to understand what is document statistics. So statistics. What statistics? Document statistics. Document statistics plays vital role in deciding what is the weightage of those text documents, how effectively they are going to be processed. The statistics gives the particular information about the task of document statistics component is simply gather and record statistical information about words, features, and documents. So it is mainly responsible for what gathering and recording the statistical information about all the words and features. And next one is documents. And documents, words, features, and documents. This information is used by the ranking component to compute scores for documents. For each and every component, the scores will be calculated. So the document statistics are stored in lookup tables. They are all stored in the lookup tables. So which are the data structures designed for the fast retrieval purpose? Here the document statistics are mainly responsible for gathering and recording the information about words, features, and the documents. So this is about document statistics. And weighing. So here the particular weightage whenever the documents are going to be processed. So weighing. Index terms weight reflect the relative importance of the words in the documents, and used in the computation scores for the ranking, Here, for example, you will be having a query, and that query consisting of you have entered Mahatma Gandhi, you entered the one particular web search query. So you want to find about Mahatma Gandhi. So I am always used to explain about one particular example. So this is what we are calling it as a web search query. This consisting of Mahatma and the Gandhi. They are the two particular words. So Mahatma is the one of the word and Gandhi is the another word. When you combine it as a phrase. So here you are able to find the score. How you are going to able to find? So the word Gandhi and Mahatma. So from the query end it is going to be processed and it is going to be transformed. And the documents consisting of Mahatma and the Gandhi. Documents consisting of Mahatma Gandhi. There are different documents consisting of information about the Mahatma Gandhi, and those documents score will also be identified. Those documents score is also going to be identified. Now the specific form of the weight is determined by the retrieval model, obviously. So this is the one of the important word you try to understand, retrieval model. So the models will be built based on that. It is the basis for the ranking even. So how the model is built, accordingly the information will be extracted. And also the weighing component calculates the weights using the document statistics and stores them in the lookup tables So this is about the weighing, and the next one is the inversion. So here it is the core of the indexing process. Inversion is the core of the indexing process here, which converts the document term information to the term document for the indexing. So here inversion. You know that the main responsibility of the indexing is there are a huge collection of the documents are available. Whenever you are going to identify the huge collection of the documents on the web, they will be identified and they will be stored for the indexing. Whenever the indexing process is going on, all the documents need to be maintained as an indexing. For example, whenever you want to search for the one particular topic in your textbook, you just open your index page and you can find the relative information required for that one. And then obviously what you are going to do is you are able to go to that particular page and you are able to retrieve the information. So the index page will improve the fast search, obviously. And here at the end of the textbook also you will be having the indexing. So that's what you try to understand. Document term. Instead of that one, you will be having the term document. So at the end of the textbook you will be having the index like hello, in which page, 92 and 94, 96. So this is the one of the best example for the inverted index. So index will be having that particular topic is present and the particular words will be present in the which document. So that's what the inverted index we can simply understand. Here converts the document term information into the term document for the indexing. Of course it's a difficult for very large number of documents. Format of the inverted file is designed for the fast query processing, obviously, and must be able to handle the updates, and compression is used for the efficiency. Whenever you will be having huge collection of the indexing, it takes more time for the processing. So for that you have to apply the compression for more efficiency. This is about the inversion. So the next component is index distribution. So index distribution, you will be having multiple computers. So the index will be distributed. So whenever you created the index, that index will be distributed among the multiple computers. It distributes the index across multiple computers, so the multiple sites, so which is essential for fast query processing, with a large number of documents. There are many variations. Document distribution, term distribution, replication. So documents are distributed and terms also distributed and their replication. So here P2P and distributed information retrieval involve search across multiple sites. Here after creation of the indexing, that will be distributed among the multiple computers, which is fast, used for the very fast query processing. So this is about the index distribution. And the second building block is user interaction. As part of the user interaction, you will be having three components. One is query input, and the query transformation, and next one is results output. As part of the user interaction, we are having query input, query transformation, and the result output. We know that the second building block is query processing. So as part of the query processing, first one is user interaction. The user interaction consisting of query input, query transformation, and next one is results output. Now I'll try to understand about the query input in detail. What is query input? So the query input, so it is the user interface. So what is query input? For example, when you are before the Google, you are doing the same task. So here Google is there, and one is the search button, and next I am feeling lucky. So here query input, here the Google is the search engine application, and the search engine, whenever you want to retrieve any particular information, what you are going to do, you are able to open www.google.com. Then you are able to retrieve this user interface like this, and you can enter the search query. You can enter the search query. So it is, you are going to give the input in the interaction, so which acts as a medium between the user and the system. So that's what it is about. The query input provides the interfaces and pass for the query language. So most web queries are very simple. Other applications may use the different forms. So the query language used to describe more complex queries, and results of the query transformation. So there may be the different Boolean queries, so INRI, and different languages you will be having, and which is similar to the SQL language used in the database applications. So information retrieval query language also allow the content and the structure specification, but focus on the content, So here the query input, so you are able to provide the input for the search engine. So that's what the query input you are giving. And query transformation, query transformation. What is query transformation? So whenever you enter any web search query, so the same we can take search, I am feeling lucky. I am feeling lucky. Here you enter the data. Mahatma Gandhi. Now, whenever you enter the data about the Mahatma Gandhi, that query will be transformed, like some of the words, query expansion, some of the query suggestions. So those things will be happened. Query expansion. So for example, Gandhi, Mahatma Gandhi, autobiography of the Mahatma Gandhi, Mahatma Gandhi ji. Like this entire web search query is going to be transformed for identifying the related documents on the web, So that's about the Google. So the information is going to identify about the Mahatma Gandhi. Here improves the initial query. So this is the initial query you have given, that will be improved, and both before and after initial search, which includes text transformation techniques used for the documents. So which includes the text transformation techniques used for the documents. Next, the another word, spell checking. So whenever you enter the word Mahatma Gandhi, in this the spell checking is also will be done. Spell checking will be also done. And next, query suggestions, provide alternatives to the original query. For this, there may be any suggestions that will also be provided. And next one is query expansion and relevance feedback. So this is about the query transformation, so which improves the initial query both before and after the initial search. Next, the third component is the results output. So whatever the process has completed in the background with the support of whenever you enter the web search query, you entered, and next you will be having ranking algorithm, and next one ranking and retrieval model. Here web search query, ranking, retrieval model, with that they are going to be generate ranked list of documents. That's what it will be displayed in the end. So that's what the results output. So construct, display the ranked list of documents for the query, which generates the snippets, which is a browsable summary of the information, to show how queries match documents, So this is about results output phase. So as part of the results output, which constructs the display of ranked list of documents for the query. And the next component is the ranking. This is the second component of the query processing. So the first component, internal component present in the ranking is scoring and optimization, and the third one is the distribution. Now we'll see scoring, how the scoring will be calculated. So now we try to understand how the score will be calculated. Now you consider the same. I am feeling lucky. You entered the query. Mahatma Gandhi. You entered the web search query as Mahatma Gandhi. Whenever you entered the query as Mahatma Gandhi, the words present in the query are Mahatma and Gandhi. Now, as we already seen that how this query will be transformed, and the document statistics, for example, what the query consisting of Mahatma is the one word and Gandhi is the another word. So how Mahatma is going to be processed and Gandhi is going to processed according to their count. How many documents that consisting of, and it is going to be calculated. For example, this is the end, and there are retrieval model is there. There are number of documents are available. So out of those documents, which consisting of about the Mahatma Gandhi and how many times that Mahatma Gandhi has occurred. Accordingly, from the user end, from the query end, it is going to process, from the documents it is going to be processed, and finally it is going to sum up with the score. So that's what here we are representing. The basic form of the query is summation of Qi, Di. So Qi and Di are the query, and document term waits for the term I. document term for the I. Accordingly, the score will be calculated. And the performance here, the performance optimization here, designing ranking algorithms for efficient processing. Obviously, designing ranking algorithm for the efficient processing, term at a time versus the document at a time processing. So term at a time will be processed and document at a time will be processed, and here safe and unsafe optimizations will be done. So as part of the performance optimization, so according to the processing about as part of scoring calculation, there is a huge task involved in the processing of calculation of the scores. Accordingly, that optimization will be done as part of the performance optimization. And distribution, so this is the third component, processing queries in the distributed environment. All the queries will be processed in the distributed environment. Here the query broker distributes the queries and assembles the results. It is going to distributes and again assembles the results. Here the caching is a form of distributed searching. It is a caching is the one of the form of the distributed searching. This is about the distribution here, processing queries in a distributed environment. So this is the main responsibility of the distribution. So what are the three components? Scoring, and next one performance optimization, and the third one is the distribution. This is about ranking component present in the query process, and the third one is evaluation. So as part of the evaluation, we are having mainly logging, ranking analysis, and the performance analysis. So what logging? What is logging? Logging user requires here logging user queries and interaction is crucial for improving search effectiveness and efficiency. So logging user queries and interaction, whenever the user is trying to interact with any one of the search engine, here how many times he is able to enter that particular query, and how he is entering that query, how he is spending, how much time he is spending on the particular page. That's what is maintained about in the logging. So that will improve the search effectiveness and efficiency. For example, you opened a particular page about Gandhi Garu, and you are able to view the different documents, autobiography, and some of the different how Mahatma Gandhi was died. So these are all the different information you want to search. Some of the links where you are spending more time, accordingly the performance evaluation will be done. So the query logs and click-through data used for query suggestion, spell checking, query catching, ranking, advertising search, and other components. So the query logs and click-through data used for what? So for query suggestion and spell checking. So what are the different queries suggested for the Mahatma Gandhi, and what are the different spell checkings will be done, and the query catching, how it is able to catch the information about the particular words or the query, and the ranking and advertisement, and ranking analysis. As part of the ranking analysis, one is going to measure how the documents are ranked based on the one particular algorithm, how the ranking will be done. So measuring and tuning ranking effectiveness. So as we know that there are different search engines out there, they are able to work on the same documents in a different manner, and when we can consider the same document for one search engine, how effectively it is going to rank those pages. As part of that one rank analysis, this will be done, measuring and tuning ranking effectiveness. And finally the performance analysis, so measuring and tuning system efficiency. How one can find the efficiency here is, we want to analyze the performance of the search engine. You will be having some of the words like precision and recall. So we are all discussing about Mahatma Gandhi. For example, you want to search about the Mahatma Gandhi Garu, then you enter the web search query, then you are able to retrieve the number of documents. Whenever you retrieve the documents, you want to find how you are able to retrieve, how many relevant documents you retrieved, and how retrieved documents are relevant. They are all talking about the precision and the recall. So retrieved documents that are relevant, relevant documents that are retrieved. So accordingly you are going to measure the performance of the analysis here, measuring tuning a system efficiency. So this is about the performance analysis. We are going to identify the performance of the search engine in that way. Here as part of the evaluation, we are having three components. One is logging, and another one is the ranking analysis, and the third one is the performance analysis. So with this we completed about the two building blocks, and now we have the question that how does it really work? How does it really work? When we have the thought process in our mind, when you can work on any one of the particular web search engine. So one of the popular search engine, we already very familiar, that Google. We will try to understand how the Google works in a particular way. So whatever the process we just discussed as part of the two major components of the search engine or two. One is the indexing process, and the second one is the query process. So they are the two building blocks. As part of the two building blocks, we come to know one is text acquisition, text transformation, and index creation. There are the three components of the indexing process, and the query process is all about the three components: user interaction and ranking, and the third component is the evaluation. So these are all the components are combiningly work together as part of the Google, and it is going to clearly present so many ranked list of documents. So what we are simply doing before the Google search engine is we are just typing www.google.com, and then simply we are entering the web search query, whatever you want to retrieve, and we are able to retrieve the information in a ranked list of documents. How the process behind the Google is working is all about how does it really work. And with this I would like to conclude today's session that in today's session what we have discussed, I would like to brief in a summarized manner. In today's class I just discussed about what are the basic building blocks. So the major building blocks are two. One is query process, and second one is the index process. So one is query, the first one is index process. As part of index process, we discussed text acquisition, text transformation, third index creation, and second building block is query process. One is user interaction, second one ranking, third one evaluation. So these are the topics we discussed very clearly about in today's class. So indexing process, text acquisition. The text acquisition again consisting of the different components: text transformation, index creation, user interaction, ranking, and evaluation. So internal components of the text acquisition we covered as crawler, feeds, conversion, and document data store. As part of the text transformation we covered what is a parser, stopping, stemming, link analysis, information extraction, and the classifier. As part of the index creation, we discussed document statistics and document statistics weighing, so distributed index and inversion. And as part of the query process, user interaction, we discussed query input, next scoring, and next one query input, query transformation, and the third component is results display. And here in the ranking, we just discussed that what is scoring and what is the analysis is going on there, and performance analysis. And the next component we discussed is evaluation. So what is logging, what is the performance analysis, and the system analysis we discussed. So with this, I am going to conclude this session. Thank you one and all.